All right, we got a narrow driveway on this project. A lot of work to do here, so let's walk on down here. I'll show you what's going on with this week's project. What we got going on here is we're going to be installing a brand new septic system to serve this ADU. This ADU was built, unfortunately, without permits, and so through the process of permitting it, they're requiring, and when I say they, I mean the county here in our area is requiring that a brand new septic system be installed for it, which is going to go down here. Currently, the building waistline for this building drains across and into the main house septic tank. So we're going to be disconnecting that and run a new building drain line down, right on down past the Kubota excavator there, setting a new tank and sump down below and building that at grade dispersal bed down there in the field beyond those apple trees. So the first thing I got to do is we have to improve this access right here. Not only do we have a narrow driveway coming down, but this is our only access down into this big field. We tried to get access through another neighboring parcel on the lower road down there, but they have a culvert creek crossing that's deteriorating, and we'd likely crush through it with the big truck. So what I plan to do here is take apart some of this fence. I've already done some of that, pull these T-posts out, and we're gonna lay a bit of plastic or something over this existing DI, and then Grant's gonna bring me out a load of base rock. We're gonna dump it and just lay that over this concrete work right here, because as these big trucks, the tank delivery truck, the 10-wheelers bringing the gravel, all that are coming down here, they're gonna have to roll over this concrete work here. And I would like to convince the owner to just rip it out anyways, because it's not looking that hot, but we're gonna try to save it for the time being and get these trucks in here, get this project done. So the strap didn't work too good, but was able to pinch it and pull it out. Pull it out enough anyways. I just got this gravel all smoothed out, and I think I could probably use one more load down in here. And we have a wet area down here by the apple tree. The tracks of my tractor are squishing into it pretty good. The truck's squishing into it, and I think I know why. They got some irrigation leaks over here. This one's squirting pretty good over there, and they got another one right over here, just gushing. Pipe came disconnected there, but anyhow, gonna have to do something with this wet area, build some dirt over the top of it. I don't want to use rock down here in the field. That would, like, unless the property owner wanted rock, but yeah, gonna have to do something with that down there, get that cleaned up, make it strong enough for the trucks to travel through there. All right, morning of day 2 out here, and this is that wet area down here by this apple tree. And I know it doesn't look like much, but we're still in the dry season. We're just about to get some more rain, but this is super soggy right here. And I think when that big tank delivery truck comes down this grade, his front tires are gonna plow and he might sink to his axles right here. So Grant's coming out. He's gonna bring one more load of base rock. We're gonna dump that up there to ramp that out just a little bit more. But then I brought some bridging fabric on the truck, and there's this natural mound of dirt here. I wouldn't say natural, it's probably pushed out of this pocket here at one point. But we're gonna lay that bridging fabric over this grass and scoop out some of this dirt, lay it over that bridging fabric, and kind of build a temporary dirt road over the top of this soft ground. So I'm hoping that will work to get this big truck in here, and also the several gravel truck loads that we got to bring in down for the act grade. So while Grant's working on that, I'm going to be down here digging for the tanks, because they're showing up here in about 3 hours. So we're going to be hustling. It's a little tight getting underneath some of these trees. Mark's pretty good. He's dodging and weaving. I'm gonna give that live oak a little bit of a undercut. There you go. All right, round 2. This time going straight down, head first. truck. All right, we did it. So this was that soft spot. We laid that bridging fabric down over the grass, just temporary. Laid in a bunch of the spoils from the tank hole, and you can see it's just squishing gnarly, right? Now just imagine if we didn't put that bridging fabric down, he'd be buried right there. So, but this ground out here is it's drier for sure. So, all right, let's get this tank dropped. All right, now that the tanks are set, the next thing I can do is lay out the at-grade dispersal area. That's the area where the effluent is actually going to hit the dirt and absorb into the ground. And all it is a very thin layer, approximately 6-inch thick layer of double washed drain rock placed on the ground, and it's going to be 8 feet wide by 60 feet long. And what we have to do is lay it out, meet the setbacks, strip the grass off, and rip it, set form boards, and fill it. Let's get after it. All right, 8 feet wide. kind of nice. Just a push and a slight twist. And you want to hold that in for a little bit just to make sure that fitting doesn't back out of there. About 2 minutes, this thing will be rock solid. All right, so this part's tricky because I want to get this pipe perfectly where it needs to be based on this assembly getting glued on here. Reducer bushing, balancing gate valve, right? So by the time this gets glued into here, I need to have a lateral that is 4 feet down from that upper board, and the next lateral is going to be 2 feet up. So this is important to me, getting this guy just exactly where it needs to be. And also that it is not coming up straight up and down. It should not be plumb. It's going to be slightly angled. It's going to match actually the slope of this. So I'm just eyeballing across the top of the board, and I'm visualizing this plane to be at a 90-degree angle right here. Perfect. All right, so we got all of our gravel placed in here. We had a little bit too much, so I made a couple piles on down the line, because once we get these laterals plumbed and installed, we can use some gravel and go over the top of those laterals. However, the problem we ran into is, out of all the materials we collected and got delivered here, we're missing our gate valves. So Grant took off in my truck to go get those gate valves. And so while he's gone, I'm going to go ahead and plumb the outlet of the septic tank to the inlet of the sump tank, put the effluent filter on, and do a few things. So let's do it. Bit of a breeze kicking up. So this is the outlet side of the septic tank. They marked it for us, makes it real easy. And we're gonna use this piece of 4-inch ABS Schedule 40 pipe to extend out so we can place a 90-degree elbow on this bench or shelf, if you want to call it. And this supports the pipe. If this pipe were in and we put a 90 on right here, this dirt around the tank would settle and it would kick the pipe down, and on the inside it would be kicked upwards. So we want to avoid that, which is why we've cut this shelf in here with the excavator. We'll take this 90 like that, glue it on somewhere around there. And this time we're using an Orenco effluent filter. And I like to remove the inner part of the filter before I glue. Get that out of there, and I'm just going to eyeball this on the inside. Alright, yeah, that should be about right. Right there. So I'm going to show you this in a second, but that filter, we don't want it all the way into the center of that manhole opening over there. We want the top of the T to be close to the edge here of this manhole opening. I'm going to show you that in a second once I get this strapped on. Turn it. And what I'm going to do is I'm going to glue this next one quickly so we can get the rotation correct on this ABS 90. Get that glue all the way around. Oh, there we are. And twist. All right. Perfect. I like to get these angled upwards, so if somebody ever needs to dig down and expose this and undo this band, they can come in from the top like this with their screwdriver. All right, using some transition glue. Good swift push, maybe a twist. Okay, so when I bed this pipe out here, I'll be coming back and checking this again. Nothing should really change, but it's always good to double check. And then later when the glue sets up a little bit more, I can go ahead and slide this down right into there. And so this is what we want to see. We want to see whether it's your sanitary tee on your inlet or outlet side of your septic tank. We want to see straight down through the tee, and ideally this opening is close to this edge. Not underneath it per se, but close to it. That gives someone room if they needed to get into the tank to get into here. So if this tee was all the way out, that would be difficult. So that's perfect. All right, so we've plumbed the outlet of the tank into the inlet of the sump tank, and this is going to be the inlet sanitary tee for the sump tank with an extension to within 4 inches of the bottom of the sump tank. And the reason for that mostly is that in this sump tank, we're going to have a conventional setup where there's a pump, freestanding pump, submersible, and there's going to be a float stand. And the floats, the switches themselves, are buoyant and they're on top of the water surface. If we don't put this extension on, then as the water pours from the bottom of this tee, it could create a rippling effect across the water, and that causes the floats to turn on and off inaccurately, with less precision, and therefore your dose out to your at grade or your leach field is going to be not very similar over time. So we're going to go ahead and couple these together with this extension. That's going to get the effluent coming straight down the sanitary tee, not causing one ripple. Yeah, and here's a view from the from the manhole end, straight up and down. Just got all that gravel placed, raked out, it's looking sharp, and you can see I put those 3 monitoring wells in on that downslope toe of the gravel. But what I'm going to do now is go ahead and uncover and start drilling the orifices in the lateral. So let's get to it. What I have to drill these laterals is this 1/8 inch drill bit. That's per plan. Sometimes plan spec calls for a 3/16 drill bit. However, that minute difference in the orifice size can drastically change the pump's performance and your squirt height. So be careful on your drill bit selection. I like to start the first penetration at least 10-12 inches away from where the box is going to be placed. We will have boxes over these valves right here. When I'm drilling that orifice, you get these little plastic guys that like to clog the hole, so take a minute, pull those things out of there. And you want to be careful when you're drilling that you don't plunge through and then drill a hole in the bottom of the pipe. Alright, so now that we got our first hole drilled, I'm just going to measure 36 inches over, and that will be roughly where my next hole is going to go. Right there somewhere. Okay, now I'm just going to do that about 40 times and I'll be done. All right, just got done laying out tools and parts and materials and supplies, and what I'm ready to start doing is building the sump. And that means pulling the pump out and starting to assemble the piping coming off of the pump, and drilling the holes through the riser that need to be drilled, not only for the pump pipe leaving the riser, but also for the external electrical splice box that is going to be able to house our wiring connections and accept a conduit that's going to run up to the control panel. And I'll go through this with you step by step and break it down, but try not to waste too much time with the actual work. So let's get to it. And I like first drilling that without the hole saw bit on there, because oftentimes when that drill bit plunges through, this wants to grab real hard and you can snap these drill bits off. So I'd like to start with that. Where did that go? Ah. All right, so here's the gate valve, right? So to drill this hole, I really want to make sure that I drill it low enough so that by the time I set the lid on here, the bottom of the lid clears the top of the valve. And so I just need to get it close. I'm gonna go, keep the top of that handle about 3 inches below the top of the riser. And I'm just gonna sight down that 2-inch PVC pressure main down there and start my hole. So this is a 2 3/4 inch hole saw bit, which gives plenty of room for the pipe and enough room for that rubber grommet that's going to go in here. There we go. All right, next I'm going to drill for the external splice box, and I'm going to be using a 5-inch hole saw bit for that hole. And in terms of planning for this hole, this splice box is going to end up being mounted in a position where we can easily run a conduit from the panel to the splice box. So I wouldn't want to put it on the back side of that. Right about here looks good. So I'm going to go ahead and get the drill bit out and put a hole through. We're going to be measuring down 6 1/4 inches from the top of the riser to the center of our hole and starting that hole. So here's the rubber grommet. It's got this wide flanger on the outside, and this has got to sit flat against the surface of the riser. So we're going to remove just about 3/4 of an inch to a 1/2 inch of rib all the way around. I should probably mention, the little flange is going to be on the inside, big flange on the outside. Just like that. All right, next we're going to mix epoxy, sand the surface, apply epoxy to the splice box adapter, install adapter with the screw hole facing up through the inside of the riser. Push firmly till it's all the way seated. Use the provided set screws. Careful not to drop them in the tank. Apply a good thick layer of ABS to PVC transition glue to the inside of your adapter ring and to the outside of your external splice box cylinder. And install your external splice box with a good push and a twist. Use your hand level and level it up. Just a couple wraps. And this doesn't really have to be super tight. You just want it in there well enough where it's secured and it's not going to just rip out of there if you try grabbing it by the pipe. using a little primer and glue, and I'm gonna go ahead and glue this riser pipe up off the pump right into this male adapter. And I've cut this 2-inch PVC pipe to be long enough once I set this pump in that the top of the pipe will be higher than my drilled exit hole. And a twist. Well, I just realized I forgot a very important part of this build, and that is the pump pedestal. It is a cylinder shaped, a very short cylinder shaped object that I'm going to be placing down into the bottom of the sump tank that the pump sits on top of. It elevates the pump up off the sump floor by about 3 to 4 inches, and since I forgot it, we're gonna have to pick this back up tomorrow. All right, I'm back, and what I got for a pump pedestal is not typical. The local manufacturer didn't have one available for me to pick up, so I went down to the local farm and garden supply place, and we picked up 2 of these 16-inch by 16-inch pavers. I have some rapid set mixed up here. I'm just gonna lay a thin layer between these two, sandwich them together, because for this pump pedestal down in the bottom of the sump tank, we're shooting for about 4-inch thick pump pedestal. That keeps this pump up and out of any potential sludge buildup in the bottom of this tank if it goes unserviced for a long time. That's what these pedestals help with. So we're gonna get this thing sandwiched together and let that set up a tiny bit and then get it down in the bottom of the tank. Let that set up and drop her down in there. All right, so while I'm waiting for that rapid set to set up on our pump pedestal, I'm gonna go ahead and cut these nipples for our gate valve union check valve assembly. And this is the assembly that's gonna go down in the sump tank in this riser, and it's gonna be connected to the pump stand right here via this 90-degree elbow. And I wanted to take a minute and tell you what this is and what it's used for. So the gate valve is the last item before your pressure main leaves the side of your riser. And the purpose for this is a number of different things. One, you can adjust the flow rate coming from the pump out to your leach field or to your mound or at grade, sand filter, whatever it is that you're building. But I would say primarily if you need to change the pump or service the pump, this is a good way to shut off the backflow coming from your pressure main in order to be able to break your union and be able to pull your pump out. So if you have a pump, it's likely that you're pumping uphill, and that pressure main pipe, however far it's going, is going to carry a certain volume of water. And that's where that gate valve really comes in handy, because if you're going to change the pump or pull the pump out, you're going to want to shut that gate valve down so that your entire pressure main doesn't drain back into the sump tank or be spraying all over you while you're trying to pull the pump out. So that's that gate valve, and that's what is so important for that. The union, obviously, you can break the pipe into 2, and you can remove this pump without having to cut the pipe, and that's what the union's for. It's got a rubber O-ring inside. It creates that seal. And then the check valve. This check valve has a rubber flap on the inside, and it only allows the water to flow in one direction. And so this is a directional fitting. It needs to be put in following the flow arrow and with this side pointing up, because we want the flap hinge to be on the top part of this fitting. And what's good about this is when that pump turns on, it's pushing water out of the sump tank. And you don't want that water to just flow back in the sump tank when the pump turns off. That's why these are so important. These can be problematic, and I would avoid using a spring style check valve for dirty water. So with all of our sump builds where we're pumping effluent, we're always going to be using a flap style check valve here. And lastly, I think the main thing for me when I cut these nipples is I want to cut these nipples where they're as small as possible. So I'm going to measure inside each of these fittings and get an idea of how long my nipples need to be. But generally it's about 2.5 to 3 inches long per nipple. And the reason why I like the nipples short is because if you were to cut the nipples too long, then this assembly grows in length and might not fit down into this riser. So you really want to cut all these nipples tight, keep all these components close together, and it'll fit right inside the riser and should work perfectly. So I'm going to go ahead and cut these nipples and we'll prime everything and get it glued together. Alright, so here's the completed assembly, and when this pump is dropped down in the sump tank, this is what it's going to look like. It's going to go right onto our 2-inch PVC standpipe coming up from the pump, and we're going to have our 90, our check valve, union, and our gate valve, and this is where our 2-inch PVC pipe exits through the riser right here. So that's what it looks like. All right, and so this is what it looks like inside the riser. That's why, oh, there's a bee right there. That's why I like to cut these nipples short between the two, because if you cut those too long, you might not fit it down inside here. So we have a rubber grommet at that height. You can see that we have enough clearance here with the top of our gate valve for our lid, and our 90, which is going to be pointing straight down towards the pump. This is kind of a key thing here because I'm about to crawl inside, set our pump pedestal block, but I want to do it where the pump pedestal block is centered to the left, right? So let me crawl down inside here, get this pump pedestal set up, then I can drop the pump in. All right, and that is pretty heavy. And unfortunately, there's a little bit of water in the bottom, but not bad. The trick really is going to be doing this without this concrete falling on my head. Oh gosh. All right, so my pump, I want that to sit squarely on this pump pedestal, and that pressure main is going to come up roughly where this little chunk of concrete is that I'm going to drop, and I use this as a sighting gauge so that I get this pump pedestal positioned just in the right spot. I don't want it too far off to one side or the other. All right, we got that pump pedestal centered up just where it needs to be. And now I am ready to set this pump, but before I do that, I'm gonna attach our pull rope on the handle, which is good practice. You wanna use the rope and not just the pipe, because if you're just using the pipe to lower your pump in and out, you could break your male adapter at the threads right there. And you certainly don't want to be lifting your pump in and out by the cord. It is heavy. And down. All right, so with the pump set, what I like to do now is use the skinny hand level. I'll come through the pipe outlet grommet, and I'm just gonna hold this level where we get that bubble just right in the center. And what I'm gonna do is I'm gonna be marking the bottom of the level on the 2-inch PVC standpipe, and that's right where I'm gonna cut it and glue on our gate valve union check valve assembly. All right, and lower it back down. So we'll check the height of the pipe. Perfect. On that 90 and on the top of that standpipe, and this is a clear primer. It's just a little neater looking because I am a little sloppy, so if I was using purple primer, there'd probably be drips everywhere. So then some clear glue. And then I'm going to push it down and give it a twist. And it is lined up with the hole, and it's also lined up with the pressure main over here, heading towards the aggregate. And we're almost done. We just got to stub a pipe through here and make our connection outside of the riser. Just a tiny bit of lube there. And you do want that to be really feeling like a good firm grip. And if it's really loose feeling, you might have a leaker there. So I'm going to clean off the lubricant on the inside off the pipe, prime it up, glue it into the gate valve. Shove and a twist. And I'm going to keep some pressure on this. Make sure it stays put while it's curing for about 10 seconds or so. That's all that's needed. And right now it still doesn't matter if my gate valve is straight up and down or not, because I can crack this union and I can twist this gate valve one way or the other, or take time to put a hand level on top of it and make sure it's level. Really doesn't matter until I connect the pipe on the outside to the pressure main. Then it'll be locked in. That's when I'm going to want to be paying attention to if this thing's straight up and down or not. Okay, I have my pipe connected from the pressure main to here, and this is going to be the last couple joints I'm going to glue. They're both primered. And now I'm correcting the gate valve, making sure that's straight up and down. Yeah, it's looking good. All right, so from a quality of work inspection point of view, not that I'm an inspector, I mean I inspect my work, I inspect my guys' work, but here's what I'm looking for. The standpipe coming up from the pump is relatively straight up and down, which it is. You know, it's not kicked off at an angle, which that would mean that your pump is not sitting flat on the pedestal. The pump itself is more or less centered on the pedestal, which it is. Our check valve, that the directional flow arrow and this side up is showing, and the arrows pointing the correct direction. That we have a union, we have a gate valve, and if this system's going to be operating, we want to make sure that gate valve is open. Otherwise, the septic won't work very well. Next thing I'm looking for is pipes passing through, and what is the pipe resting on as it leaves the riser? Is it just suspended in air for 8 or 10 feet, Well, that's not going to be very good. Or does it come out and drop down and sit on something solid like the top of the tank or a shelf, which it does. Yes, there is this span right here, but with some careful bedding work, we're going to be able to support that pipe. And then lastly, one thing you can check is, and where I see some people go wrong, is cutting the elevation of that standpipe. So we took time, we used that skinny hand level, we came across, made our mark, cut our standpipe, but how you can really tell if this all didn't work out right and maybe the pipe was cut too high or too short is go ahead and break your union and then see how well these two pipes align. If you go to put that union back on and you have to push down or pull up or push down on this pipe to get your union to go back together, then you know something's not quite right. Maybe the pipe was cut too high or too low. But we are looking good. We can take that on and off easily. These two line up really nicely. And so yeah, that's what I would look for from a quality of workmanship point of view. All right, now that is done, we can go ahead and connect our conduit from there and up into the panel. We could put our float stand together, so let's get to doing that. All right. Okay, just got these conduits all put in here, and we went 1 inch for our power supply, and that 1 inch is also going to be the duct for the remote alarm wires that are going to go all the way back up to the house. So I have a secondary little remote alarm box in there, and per code here in Sonoma County, if your septic system control panel is greater than 75 feet from the residence, you need to have that remote alarm box up by the house. And so that's why we went with the 1 inch. Give us a little extra room in there. And it is greater than 70 volts, so it's not low voltage. It can go in the same conduit with the high voltage wires coming down for the power supply. Got our conduit in here, going over to our external splice box, and that's gonna house the wires for our floats and the pump wires coming back up into the panel. And inside the splice box here, when I get those pulled in, we have these blue silicone filled wire nuts, water resistant. So yeah, that's where I'm at now, and I think what I can do next is go ahead and set up this float stand. But I wanted to say one thing that that I like to do for these installs is get this conduit down low as you can. Here it was easy to get the conduit right on top of the tank, and that means when we backfill, that dirt is going to come down and it's not going to take the conduits with it and settle those conduits down and tweak the pipes. Those pipes are resting on something that's solid there. So yeah, let's go ahead and get this float stand set up, and I'll show you what that looks like. All right, there we have it. That's a float stand for you, and real basic design. It's just 1 inch PVC pipe. We casted the bottom of that pipe into some concrete there. It's actually rapid set, non-shrink grout, coupled onto it with a coupling. This is our bottom float. That is your pump on and off float switch. It's just like a light switch, completes an electrical circuit, and that will turn the pump on. And the next float up, this little guy, is a short angle alarm float. That's just to turn the alarm buzzer and the alarm light on to notify you that there might be a problem inside your sump tank. So obviously if the water level gets up and over your pump float and your pump doesn't turn on, your pump's not pumping the water down, the next thing that's going to happen is that water level is going to rise, and it's going to float up your alarm float at the angle that's going to complete the electrical circuit, and that's when your buzzer's going to go on. So that's all there is to it. I have these zip ties on here, just loose right now. We're gonna, once we get some water in the sump tank, we'll actually set these floats very specifically for a dose as designed. But this is just gonna drop in like so. And if you'll notice, I have the two floats. They're not only separated on the PVC pipe from one another, but they're at 90 degrees from one another, which is just something I like to do, so that at no point whatsoever are they going to interfere with one another as they're swinging up and down. And also those floats, as I lower this float stand in, they're pointing and they're going to be operating away from the pump. And I'll show you how this works. Just a hook handle there, drops in like that. But what's important is that those floats down in that sump tank aren't going to be having any interference with other cords or any other ropes. So it's good to have those floats pointing off and away from everything else, and have all your wires inside your sump tank pulled up and secured neatly out of the way. So that's it. That weight holds it down. It doesn't move around. It's got this little hook handle here, and it's real easy for a pumper or anybody to just come grab this handle and pull those floats up and out of there. So we already have our wire for the pump in this splice box, but I'm going to go ahead and take our lowest float, our bottom float, which is the pump on and off float switch, and I'm going to put it through that lower gas tight fitting right there, and then I'm going to pull about 7 or 8 inches of that up and out of the top. I like about a fist and a thumb's worth to work with, because I'm gonna have to strip that and make those connections with the silicone filled wire nuts. And when I get that cord through, I'm gonna go ahead and tighten this down pretty good. Not super good, because these are plastic and they can crack. So just a good snug, and typically you just give it a tug. This is still a little bit loose. See, I can move it there. That means I got to tighten it just a little bit more, and that's how I know when to stop tightening it. Okay. All right, got this plumbed into the tank, and let's go up there and get the rest of this put together, including the conduit. All right, here we go. Whew. Got it, guys. Plenty of fall. She's a beauty. Looking good. All right. All right, so this is gonna work good for filling the tanks with water, because they're way down there in the field. And I'll just shove this in this two-way clean out here and get the hose running. Get it in there a little way so it doesn't come flying out of there when we turn it on. There we go. Cool.
All right, so got these all done. Gopher wire, rapid set in there. Any kind of small hole that a little gopher can crawl through is plugged, and yeah, not a beauty contest, but very functional. And boxes are nicely set where they're evenly spaced and evenly sloped. So yeah, I'm happy with that. And we are ready for our inspection tomorrow. I am waiting a little bit longer, filling up the tanks with some water here this evening, but I'm gonna run out, grab some dinner, come back, get these tanks topped off all the way, and we'll be ready. Just passed my inspection, and this inspection was just covering the water tightness test on these two tanks here, as well as the squirt test of the at grade, and that's checking to make sure the pump runs and that we are achieving at least a 60-inch high squirt at the at grade out there. They check a few other things like Schedule 80 conduit coming up out of the ground. We check setbacks, we check accuracy compared to what the design was and what was actually installed, to know whether or not an as-built drawing would be required. And yeah, everything went really good, and thought I'd throw out a tip for you guys out there. Because these tanks were really full of water for that water tightness test, what I like to do is I like to get the at grade covered and get that all backfilled before we pump any more water out to that dispersal field. Because these tanks are really full of water, I just opened up this cap here on the sump and let a bunch of this water drain out into the loose backfill material around these tanks. And that's kind of killing two birds with one stone. We're removing as much water out of the tanks as possible to get it closer to its normal operating height, which there's still several hundred gallons inside the sump tank that will need to be pumped down to get it below the alarm level, so that our buzzer is not buzzing. But we're not only getting the water out of the tanks, but we're helping to settle the dirt around the tanks, which is very helpful. And then also keeping our dispersal area as dry as possible while we're still working out there. And we're going to be backfilling. We're going to be driving up and over the top of this gravel bed, not on the gravel, but the weight of that machine will be applied through you know, the 12 or so inch thick layer of soil down onto the gravel, and that gravel is going to be pushing on the ground. And I think anybody with some common sense would know that you wouldn't want to do that and disperse all this water out of these tanks into this gravel bed right now and be driving over it. So long story short, the way I like to do things, and my tip for you guys out there, is backfill this while it's still dry, and you can use some of that extra water around your tanks to help settle the dirt. But with all that being said, I have a lot of work to do. I'm gonna get after it. The steps here coming up real quick: pull the form boards, snap the orifice shields over the pipe orifice, then cover with filter fabric, and then we're ready to cover with dirt, and then all the other backfill that we got to do. So let's get after it.